Welcome. This is our lesson on triangle congruence. So the first thing we should probably discuss is that concept that we did earlier about correspondence and how we have congruent figures. So if we just talk about triangles for a moment here, and I'm trying to get my machine to cooperate here. If we talk about correspondence here, remember in a triangle, we have 6 things, 6 parts that are congruent. 3 sides and 3 angles, correct? So if you have congruent triangles, then you know that these 2 things are true. So what we want to do is see if there are shortcuts. Because we don't want to have to show that their 3 sides are equal and that 3 angles are equal. That's 6 parts that we have to prove congruent. Well, if there's a shortcut, then we can save some steps. Well, that leads us to our first, what we call theorem, which we're going to be doing proofs in 2 lessons. 2 more lessons we'll be talking about proofs. And I'm not going to lie, they take some work, to say the least. Okay, so what this side angle side congruence theorem tells us is that all we need are 2 sides and an angle that's between them, or what we say included. So in this case, if you look at the tick marks, AB and DE are congruent, and AC and DF are congruent. 1 tick mark, 2 tick marks. And the angle between them is also congruent. So by the side angle side congruence theorem, these 2 triangles, triangle ABC, would be congruent to triangle DEF. Now you got to make sure and match them up correctly for the congruent statement. But the reason is because of side angle side. We don't have to show that 3 sides are congruent and 3 angles are congruent. We only have to show side angle side. So if you look at this problem, it says in the diagram, segment QS and segment RP pass through the center M of the circle. What do you call QS and RP? Those are called diameters. They're the diameter, each of them is a diameter of the circle. Well, can the diameters be different? No, they cannot. Well, what do you call MQ, MP, MS, and MR? Those would be what? Radii. Each of those is a radius. Well, a radius has to be the same. So MQ, MP, MS, and MR are all the same length. So that's why I'm going to put tick marks on them. Well, I have side, side. Now, I know a lot of you want to say that SR and PQ are equal. Well, we can't prove that. You can't show that, hey, they should be, but we can't say they are for sure. What we can say for sure is that vertical angles are congruent. So these 2 triangles would be, triangle MRS would be congruent to triangle MPQ by side angle side. See how that matches up all perfect? Okay. So let's look at this problem. ABCD is a square with 4 congruent sides and 4 right angles. R, S, T, and U are the midpoints of the sides, and also RT is perpendicular to SU, and SV is congruent to VU. Now that is a lot of things going on there. So if we're gonna prove these 2 triangles, these 2 things, then we need to slow our roll here a little bit and go through what the statement says, this up here. First of all, ABCD is a square with 4 congruent sides and 4 right angles. So that means that A, B, C, and D are all 90. R, S, T, and U are the midpoints of the sides. Well, we know that all 4 sides are equal in a square, so the midpoints divide all of these sides equal. Well, what are each of these little triangles? AUR, DUT, TCS, and BSR. Right, they're all isosceles, aren't they? Isosceles right triangles. Then it also says that RT is perpendicular to SU. RT and SU. So that's 90. And it says that SV is congruent to VU. So I should put 2 tick marks on there. Okay, now we're supposed to prove that SVR is congruent to UVR. SVR is congruent to UVR. SVR, UVR. So if you look at this triangle and this triangle, they both have right angles there, correct? So far we only know one shortcut, and it's side angle side. So can we say that's side angle side? Well, no, we can't. Not yet. But they both share RV. So then it would be side angle side. Side, angle, side. This side and this side, these angles, and then they share that common side. So that would be side angle side. Now it says prove that triangle BSR is congruent to DUT. Well, that's this one up here and this one down here. Well, that's clear. Side angle side. Side, angle, side. So this is pretty easy when you really get down to it. Now the other shortcut, the way we can prove triangles congruence, is the side, side, side theorem. So far, we have side angle side where the angle is included. It must be between the congruent sides. Okay? Side, side, side now is just simply all 3 sides are congruent, like these 2. Okay? So, decide whether the congruent statement is true. Explain your reasoning. Is triangle DFG congruent to triangle HJK? So 2, 3, 1, 2, 3, 1. That is a yes by side, side, side. Okay? Number 2, triangle ACB and triangle CAD. Well, CA and AC are both 9, so I'll put a tick mark there. AD right here is the same as CB, but 3 and 4 are not congruent, so that's not true then. Side, side, side wouldn't work. Okay, what about 3? QPT and SRST. 2, 3, 1, 2, 3, 1. Yep, that'd be side, side, side. So it's not always going to work. Now the third and final theorem that we're going to use as a shortcut only works in right triangles. It only works in right triangles. It only works in right triangles. So, hypotenuse, leg. So any hypotenuse are the same and one of the legs are congruent in a right triangle. That ensures triangles are congruent. So in number 7, it says redraw triangle ABC and triangle DCB side by side with corresponding parts in the same position. Okay, all that means is this. I'm going to draw BCD, and then I'm going to flip, and I'm going to draw the other one so it looks exactly the same. Well, that's B then. This is A, and that's C. Let's see, that says that's equal, and that's equal, right? The hypotenuses are equal. Now, what other part is equal? Well, isn't BC congruent to CB? BC, CB? Are those triangles congruent then? Yes, by hypotenuse leg. Now, you may think side-side angle would be the reason, but that does not work, okay? The only reason this works is because it's a hypotenuse and a leg. That is the only reason. So HL is what the reason is on that particular congruent statement. So in summary then, there are 3 ways to prove triangles congruent so far that we've learned. Side angle side, side side side, and hypotenuse leg. Now this one must be a right triangle in order for you to use hypotenuse leg. So the angle here on side 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 must be included. And what that means is this. If I just drew a triangle here and I click that side and that side, is that angle included? The answer is no, because this would have to be the included angle, because it'll be in between the 2 congruent sides. So you have to be aware of that and be careful where that angle is located. Side, side, side is just simply what it says. All 3 sides are congruent. Corresponding sides are congruent. Okay? Now's a great time to look at your big ideas and see what the assignment is, and go do it knowing these 3 new facts.